Welcome. So in this lesson, this is an advanced lesson and we're going to go through a year 9 concept. So that means it is not going to be assessed this year. It's going to be about perfect squares. Our learning intentions: to be able to identify a perfect square, to be able to expand a perfect square. Now, what are you asking yourself at the moment? You're probably asking yourself, what on earth is a perfect square? Well, here is a visual representation of a perfect square. And as you can see, it's a square. How do I know this is a square? Well, as you can see here, its width is x plus 3, x plus 3. And its length is x plus 3, x plus 3. And remember, the definition of a square is that the length is the same as the width. So we're looking at here a square. If I wanted to write down the area of this square, I would go x plus 3 times x plus 3. So in a sense, I'm going x plus 3 times itself. The best way to write that is like this: x plus 3 squared. Now let's just take a step back. Why am I writing it like that? Because I know it's simply x plus 3 times x plus 3. So this represents my length, this represents my width. So this is a perfect square, and this is what a perfect square looks like, x plus 3 squared. So when you see something like this, you think to yourself, that is a perfect square. Perfect square. Now, the next thing we need to know how to do is how to expand a perfect square. And we learned how to do binomial expansion in our previous advanced lesson. That's when we went, hey, that's x times x is x squared. And we know that would correspond to this area right here, x times x. Then you'd go x times 3 is 3x. And that would correspond to this area right here. 3 times x is 3x. Then 3 times x, so plus 3x here. That would correspond to this area. 3 times x is 3x. And then the last one here is 3 times 3. Now I'm going to leave that as simply 3 squared. But we know that 3 times 3 is going to be 9, but let's just leave it like that for the time being. Perfect. The other thing I want you to take note of here is that I have this area here, which is 3x, and I also have this area here, which is also 3x. So those highlighted portions there are equal in area. So that means if I wanted to, instead of going 3x plus 3x, I could go x squared plus 2 times 3x plus 3 squared. If I now were to simplify this, I would say it's x squared plus 6x plus 9. And that's what we would do. That would be my answer right there. Fully expanded. What we're going to be learning in this lesson is how to expand a perfect square in the most time-efficient way possible. So as you can see here, this took some time. We had to draw in arrows and collect like terms, kind of a waste of time. But if we know some key facts about perfect squares, we could answer it quite quickly. We could simply say, hey, square the first term. So that's going to be x squared. Then you could say go plus 2 times 3 times x. 3x. Then you could go square the last term, 3 squared. Then you could go, all right, it's going to be x squared plus 6x plus 9. And would you look at that? We got the same thing. We got the same thing, but look, we only had 1 line of working, when here we had 2 lines of working. I mean, this is a lot more of an efficient way to do it. It's quicker. It's a lot quicker way of doing it. And soon you can do it with no lines of working at all. You can just immediately write down what the answer is going to be if you know this. Let's go through another example here. So here is another perfect square. The way that we're going to write it is x plus 5 squared. So remember, this right here, my friends, is a perfect square. It's a perfect square because the length is the same as the width. Using my technique now, I could say, hey, I can square the first term because that's going to correspond to that region. Then I could go 2 times the product of these 2 terms, so 5 times x is 5x. The reason why that works is because I know this area here is 5x, and I know this area here is 5x. So I'm going 2 times that area. And then lastly, I'm going plus the square of the last term, so 5 squared. And that's going to correspond to this right here. So then, if I just simplify this, it's going to be x squared plus 10x plus 25. That is my answer right there. Let's appreciate that that's a lot quicker than doing it the alternative way. The alternative way of expanding it is doing this. X plus 5, x plus 5. Then you have to draw in arrows like this. Then you have to go x times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Gather the like terms. X squared plus 25x, plus 10x, 5x plus 5x is 10x, plus 25. You can see that we get the same answer, but it's a lot less efficient. Let's just finish this page by looking at some theory here. So as you can see, the theory behind expanding a perfect square is that if you're given something like this, so a plus b all squared, what you do is you square the first term. Then you go a times b, and then multiply that by 2, and then you square the last term. And just like that, you have your expanded version of a perfect square. Okay, let's now move on to our next page here. Now, this is a bit harder to draw, but I've drawn another perfect square, but what you'll notice is that we have these red regions here, and those red regions represent negative area, something that's kind of hard to draw. What this would be right here, if I was to represent the length of it, it would be x plus negative 3. Now remember, when you're plussing a negative, it's the same thing as just going x minus 3. And so too on this side, it's going to be x minus 3. So that means what my formula for the area would be is x minus 3 squared. And this is a perfect square. So when you see something like that, you know you're dealing with a perfect square. We can use the same technique we did above. So if we want to expand this, we would simply go square the first term. That's going to correspond to this region right here. We would then go plus 2 times the product of these two things. So it's going to be negative 3 times x. So that's negative 3x. That's going to correspond to this region right here. So negative 3 times x is negative 3x. And then negative 3 times x is going to be that region right there. Now, this is negative area, right? So that's why I've done it in red. And then finally, we're going to have plus the square of the final term. So it's going to be minus 3 squared. So that means if we now were to simplify this, I'm going to get x squared. 2 times negative 3x is negative 6x. Then I'm going to get plus 9, because negative 3 squared, that's negative 3 times negative 3, which is positive, so positive 9. And that corresponds to that region right there. And you can see it's green because it's a positive area, because you're multiplying a negative with another negative. And that's how you would answer it. And I think you would agree with me, that's a pretty cool way to answer the question. If you were to do it the long way, what you'd have to say is x minus 3 squared is the same as x minus 3, x minus 3. Then you draw in your arrows and go x times x is x squared. X times 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. X squared minus 6x plus 9. That is going to be our answer, and that is the same as that. But we don't want you to use this technique. When you're dealing with a perfect square, we want you to think in these terms right here. All right, final here. The way that you'll learn how to do this soon is kind of doing no working out at all. You'll look at this and you'll say, hey, this is x minus 5 squared, because this here is x minus 5, and this is x minus 5. And what I mean is you'll be able to expand this with no working out. This is what you're going to do. You're going to go, hey, we square this one, x squared. Then we go 2 times negative 5x. That's going to be negative 10x. Then we go square the last term, plus 25. Would you look at that? We did that question with no working. We went x times x is x squared. Then we went negative 5 times x, that's negative 5x. And hey, we've got a negative 5x, another negative 5x down here. And then finally, we have negative 5 times negative 5 is positive 25. When you add these all up together, you get x squared. negative 10x plus 25. Do you see how efficient this method is? This is expanding perfect squares. How amazing is this? All right, so we come here. This is our formula when we have a negative here. So it's exactly the same as the other one. So it's a squared. Then you go a times negative b times 2. So that's negative 2ab. Then you go negative b squared, positive b squared. Okay, let's now go into the questions you're going to be facing here. So it's going to say, expand the following. And how are you going to do it? You're going to go square the first term, plus 2 times the product of these two terms, negative 2x. Then plus the square of the last term, negative 2. X squared stays the same. This is going to become negative 4x. And then finally here, we're going to get plus 4. That is your answer. We come over here. We do the same thing. We go square the first term, plus 2 times the product of these two terms. 2x times 3 is 6x. Then we go plus the square of the last term. 2x squared is 4x squared, plus 2 times 6x is going to be 12x. Whoops, that's an ugly x. And then 3 squared is going to be 9. That is going to be our answer. Let's now do the next one really quick. You square your first term, 9. Then you go 2 times the product of these two numbers. Negative x times 3 is going to be negative 3x times 2 is negative 6x. Then you square your last term. Negative x squared is going to be plus x squared. And people, this is correct, but people like to put the x squared first, x squared term first, then negative 6, then the plus 9 there. But both of those are correct. But people just like putting the squared term at the front. Let's do the next one. I'm going to square the first term. I'm going to square the first term. I'm going to square the first term. Can't talk. 10 squared is 100. Then I'm going to go 2 times negative 4x times 10. Well, negative 4x times 10 is going to be negative 40x. Then I'm going to times it by 2 is going to be negative 80x. Then I'm going to square my last term. Negative 4x times negative 4x is going to be plus 16x. Squared. Negative 4x times negative 4x is going to be positive 16x squared. Then I can just rearrange it. 16x squared goes at the start there. Then I have negative 80x. And then I have, what is that? Then I have plus 100. Do you see that you can answer these questions lickety-split? If you have kind of this formula in your head, you square the first term, then 2 times the product of the two terms together, then square the last term. And then just like that, you're getting your answer. Amazing. All right. Hopefully you found this helpful and interesting and realize that this is advanced material. You're not going to see this year, but hopefully you just found it interesting, and I'll give you some activities just so you can brush up on this skill. And with that being said, I will see you in the next lesson.